Hello, hi, this is Vikas Shakya, and today we are going to discuss something about the critical section. So, let us make some basic understanding about the critical section. Suppose there is a washroom, or you can say a lavatory, and there are a number of people who want to access that washroom, right? So, if you want to use the washroom, then only one person at a time can go to the washroom. It's not like two-person can enter into the washroom. This is a small washroom and only one person can enter into this and only one lavatory is there, right? So suppose some person went inside, then what he will do, he will just lock the door from inside, and when someone from the outside try to come and try to push that door to enter into the washroom, he will know that someone has locked it from inside, right? So that way the other guy will know that yes, there is someone inside and I cannot go there. So what is it? It's if you create an analogy, then we can understand the washroom as a resource and the number of people who want to access that washroom as the threads. Right? In a process, there are a number of threads. Similarly, number of people who want to access the washroom, they can be treated as a thread. They can be thought of as a thread, and the washroom that they want to use is the resource. And same thing happens most of the times when we program, when we are writing some program, especially when we are writing some server-side programming. Then in that case, most of the times what happens that we have to take care of this thing, that there are a limited number of resources, or there is only one resource, just like a database connection, and only one person at a time should be allowed to use that connection. Other threads should not be able to access that database connection if some other thread is accessing that. Right, so this is all about the basics of the critical section, why we use it, and what are the needs of using this. And these are only the examples, and there can be many situations where you want to use the critical section to synchronize the access to some resource. Right, so now I'm going to tell you, I've written some program and I want to tell you that how it is used. Right, so let's see our program, where it has been written. I've already created one program for you. So this is my program. You can see here, it's my main function, and I have declared one critical section, and there is an array, and there are two threads, writer and reader. These are the functions for the threads. These are the entry points for the threads, writer and reader. So what is the objective of this program is that when writer will be done writing in an array, then only reader should be able to read from it. Right, so we basically are synchronizing the two arrays, the two threads, reader and writer. If reader is reading, then writer is not going to write something on it, and if writer is writing something, then reader should not be able to read from it. Right, so I have used the critical section object. This is the array. These are the two entry points for the two different threads. Right, and what about this critical section? This critical section is declared in winbase.h. If I do F12, then I can reach to this winbase.h, where this has been typed def structure RTL critical section. So original structure, data structure which is used is RTL critical section, and you can see it here, RTL critical section. Right, so if you have this RTL critical section, if you want to understand this, what is the meaning of these variables, lock count, recursion count, owing thread, lock semaphore, and spin count, you can simply go to the MSDN and Microsoft site, and you can understand what is the meaning of these. Right? But for now, we are not bothered about it. We just want to see the concept. So let's back to our program. So what I have done, here is the critical section. I have initialized this critical section here, and I have deleted it before the end of the main function. And this should be remembered that initialization of the critical section should be done before initializing any of the threads. I have initialized two threads, the writer thread and the reader thread. Right? There is one thread writer, there is another thread reader, and we should initialize this critical section before creating any of the threads. Why? Because if thread gets scheduled, then if this critical section has not been initialized, in that case, if it will use this critical section here, it will try to enter critical section here, and your critical section has not been initialized, then the behavior could be undefined. It may be that your program get crashed. Right, so all the synchronization objects, whether it's a critical section, it's mutex, anything, you should initialize it before using it, before you create any thread, and that too specifically when you are creating the thread in scheduled mode. Just like this thread, if you see, this is the writer thread, and this is the entry point function which I have mentioned here. You can read about the create thread function from the Windows APIs on the MSDN, and this is the second last argument which tells that whether the thread will be scheduled immediately or it need to be suspended and someone else will schedule it later in the course of the program. So if you pass 0, then it means that your thread will be scheduled immediately, right? If you use this create suspended, in that case it will not be scheduled immediately. It will wait till someone schedules it, right? And you can use resume thread function to schedule it. Okay, so I have written this th writer, th reader, and then I have done this thing. I have created an array of handles where I have provided this reader and writer handles, and then I have called wait for multiple objects function. Here I have provided the number of threads which I need to wait, and the array where the handles of these threads have been mentioned. And true means, third argument is true. True means until all these threads are done, I should not return. And infinite means I need to wait infinitely till the time these two threads are done, right? And once these two will be done, then I have deleted the critical section, I have cleaned up all the things, and then it is returned, right? If you will not use wait for multiple objects, then what will happen? Your program, your threads will not complete, right? Because your main is also a thread, and once it will return, it will not wait on it. It is not going to complete this reader and writer thread, because these threads have been created inside the main function. These threads have been created from within the process, right? Within the program. So this is the main thread. Once it will be done, program is done, right? Main thread is the thread. When it is done, the program is done. And since it will get the time slice, and before these threads are done, you will be able to return, right? So if I do Control F5 and if I run it, and I have commented that build for multiple objects, wait for multiple objects, then in that case, you will not be able to see anything. It will simply say it's done, means press any key to continue. Okay, so it's done, means reader and writer thread contents have not been shown. Right, so now let us see what happens when we do wait for multiple objects. Now in this case, our program will wait for reader and writer threads to complete, and you can see that in the writer thread, the program is entering into a critical section which I have initialized, and once it has put the lock, it will put the values at the various indexes of this array. Until the time it is putting the values to the various indexes of this array, this reader will not be able to read anything, because as soon as it will call enter critical section and the writer has already acquired the critical section, then it need to wait. This enter critical section will wait, right, until this is done. Okay, so once it will be done, then reader will be able to read the values at the various indexes. And to make it fancy, I have used a sleep as well, so that when it is writing to the index, it can show you that I'm writing it in this, and same thing has been done for the reader. Here I also use the sleep, and after 1 second, after each second, you will be able to see that the value at this index is this. Okay, so let's execute this program. And one more thing, here I have created the writer thread first and the reader thread later. But you should not follow this practice. Why I have done this? That my thinking is that if I have created the writer thread first, then this thread will be scheduled by the operating system first. But you should not take this as a concept. You should not take this as a principle. It cannot be true always. It may be there are certain situations that writer thread was not scheduled immediately by the operating system, but reader thread got scheduled even if it was created later. Right? So what we will do, we are going to just see what happens in this case, but you should not use this, you should not follow this practice. You should use some other way, like you can suspend the reader thread for a while, and until the writer thread is done, you should not wake up the reader threads, right? So this can be done, but always follow this rule that don't assume that if your thread has been created first, then it will get the time slice first. No, it is not always necessary, right? Okay, so let's process it. Let's run it. Control F5, and when it is running, okay, so writer thread has got the time slice, and it is writing, and writer thread has placed a locked as well, just like you can see in the program itself. Once it is done writing, then it is showing you the values at the various indexes in the reader thread. So this is reader thread which is going on right now. Done. Okay. And there is one more thing. Sometimes it happens that you are not able to, your thread is not able to find the time slice. Basically, it's starving. And this happens when you have not written your program correctly. There are some loopholes while using the synchronization objects. Like if someone forget to write this statement, leave critical section, then what will happen? This reader thread will keep waiting forever. So let's see. I have just commented this so that only intercritical section is there, leave critical section is not there. Let's see what happens. So writer thread has got the time slice, it is writing. But after the writer thread, reader thread is still waiting. Even if the writer thread is done, reader thread is not able to get the time slice. And that is why it is waiting forever, right? It was waiting forever, it will keep waiting forever. This leave critical section is commented, so writer has entered into the critical section but it has not left the critical section. And this reader is waiting for someone to call leave critical section, which has not been called, so it will stuck here. Right? So since it has been stuck here, you cannot afford this program to run. You need to fix it, right? And the fix is leave critical section. You need to write somewhere at the correct place, okay, wherever the intercritical section has been called, but leave critical section has not been called. Okay, so now I said that it will wait forever, but what is the meaning of forever? If I have not, if not written this statement, and then this will then this reader thread will wait forever. Then what is the meaning of this forever? Is this forever means will keep waiting? If your program is running for 20 days, 30 days, it will keep waiting, and it will not throw any exception. It will not show anything. No, this is not true. Actually, there is a key. If I show you, this key is in the registry. Let me open the book. In the critical sections, I can show you that there is a key in the registry. And what's that key? This key is here. Local machine system. Let us open that using registry editor. I'm opening the registry, Windows registry. Okay, so what path has been written? H key local machine. Then there is system. There is current control set, and then we have control and then session manager. Control and then session manager. Okay, so in this session manager, you can see this critical section timeout is a key. Right, this has been given as 259200. This is in seconds. This is not milliseconds. This is in seconds. Right. If you convert these seconds into days, then it comes out to be 30 days. Right. So it means after 30 days, this is the critical section timeout. It means forever means this value, these many seconds. So if you leave this program running for 30 days, then this program will show you an exception. This program will throw you an exception, right? So this is the meaning of forever. It's not like forever means it's forever. No. How it will calculate forever? There is some limit. So it's set by the operating system. by the Windows. When you install it, then all these things are set by the operating system itself. Okay, so forever means these many seconds which has been mentioned in the registry in that path. Okay, so if I do this, leave critical section, then it will run properly. If you want to see what will be the impact of modifying that value, which I have shown you, critical section timeout, you can see that. You can set it to 2 seconds. I mean, 1 to 2 minutes, right? Don't set it 2 seconds because this critical section object is not being used by only your program. The critical section have been used by many processes that are running for the Windows, and they are system critical processes. And if you make it 2 seconds, then it may be that there are some system critical exes which are running there behind the scene, and they keep failing once 2 seconds is done, right? So don't do that. If you want to see that, you can just write there 2 minutes, and you can give the seconds, number of seconds. If 2 minutes means 120 seconds, and then you can run this program and just leave this critical section, comment it, and then you can see what happens, and you will be able to see that after 2 seconds, after 2 minutes, you are able to see that your program got crashed or it thrown some exception. I will try to do this. Okay, let's do that. Let us see that what happens. I am going to modify that value. I will make it 3 seconds, 3 minutes, and be very careful modifying it because it may be that you are done once you are once you have given the wrong value, right? So I'm going to give in seconds. It's 3 minutes, so it's 180 seconds. Okay, so it's 180 seconds. Let me make it 180 seconds. It's done. So now I'm going to run it again. I'm just going to open it again. I will open the development environment again, and I will open the same program again. My system is a bit slow, so you need to be a bit patient. Okay, so it's critical section, and now let us see what happens. I will just comment that leave critical section for the writer process, and let's see for how much time my reader thread executes, and if it is able to throw you the exception, right? So I'm just trying it. It's not like it may work right now, but this is the concept. It may be that I need to restart my system to make that effective. I'm not sure about that, and you can find that out from various sources like Google. And let's see what happens. I'm just going to run it. Control F5. Writer will be done with writing, but it will not give any time to reader. Will not remove the lock which it has done. Build succeeded. Let's see what happens. Writer has got the time slice. That's good news. Writer is writing at the various indexes, and after it will be done, reader will not be able to get the time, and then we will wait for 3 minutes. Let's wait for 3 minutes. what happens. I think it's almost 1 minute done till now. We need to see what happens at the end of third minute. You can just move your video ahead, because I am waiting for 3 minutes, right? So you don't need to wait for 3 minutes. You can move your video ahead and you can see the results. So I think by now it's almost 3 minutes done, because I started at 9:10, but it's now 9:13, so I think time is almost done. So I will just see it for 9 till 9:14, and after that I will close it, because I think I need to restart the system before those changes could make effect, right? So concept is there. I have explained you the concept, but I cannot show you, because it may be that system need to be started. Okay, so you can try this on your system, but this is not that much necessary. Just keep it in your mind. Okay, so it's 9:14, so I think I need to restart the system to make that effective. So I will not be able to show you that, but keep the concept with you. And the last thing now that I would like to tell you, that apart from this intercritical section, there is one more function which is called try intercritical section. Okay, this is also the same thing. You can use it same way, just like you use intercritical section, and this function returns Boolean value, right? If and what is the difference between this and this? This try intercritical section will return immediately if the critical section object is not available. This intercritical section will wait till the time object becomes available, but this try intercritical section will not wait. If the object is not available, critical section object is not available, what it will do? It will simply return false, and you will know that yes, there is no object available. The critical section is already acquired by someone, so I cannot enter into this, right? And this can be used at many places. I'm not sure where you will use it, but this can be used. I can think of some situations, but not a good practice to use this try intercritical section until there is a specific requirement. Okay, so this is the other function. And one more thing, if this function returns false, it means that someone is using that critical section, right? And it returns false, then you don't need to do anything. You don't need to call this leave critical section. But if try intercritical section returns true, it means this critical section has been acquired by someone, and he has released it, and this has been available now. This critical section is available now. Then in that case you will get the true, and true means critical section is available, and this try intercritical section will put a lock. Okay, once it will put a lock, you need to release that lock, and there is only one function to release the lock, leave critical section. So let's see by example. we know that our writer thread is able to get the time slice first. Okay, so here I am going to use try intercritical section, and here I am going to use try intercritical section. Okay, so what I will do, here I have written bool b is equal to try intercritical section, and what I am doing, if b, then only do this. Right, in this case what will happen if I don't write this, if b is there, right, then in that case it will write the values at the various indexes, but it has not been called leave critical section. It is not calling leave critical section. So in this case as well, reader will keep waiting. Right, for reader I'm not using try, I'm just using intercritical section. So let's see what happens. Now reader thread has got the time slice this time. This is the thing which I was telling you, that is not necessary that your writer will always get the time. It's your reader which may get the time. Right, so this time it was not able to show you the thing which I wanted. So let's see for the writer thread. Let's try this time if writer thread get the time. Okay, writer thread got the time this time. Writing at index 0, writing index 1, every index it is writing. And after that your reader is still waiting. Right, your reader is waiting. Why? Because try intercritical section for the writer thread returns true. It has returned true. Right, so it has returned true, but it has done all its task, but it has not called leave critical section. So you need to call leave critical section here. So this is the way you should work for try intercritical section. There is one more function I would like to tell you about that. Apart from this initialize critical section, there is one more function, initialize critical section and spin count. You can use this one as well for your initialization of the critical section, but please remember that if your system is a single process system, then this spin count, you need to provide the spin count. Suppose I provided 100. Okay, so even if you provide this value, this spin count value will not have any impact. It would be similar to, like, it will be same as initialized critical section if you are running on a single process system. Okay, so what is the significance of initialized critical section and spin count? Basically what happens that whenever your thread is waiting for any critical section object to be freed, then what happens that if it finds that yes, this critical section object is not available, then what happens that thread immediately goes to the waiting state. Okay, so what happens, like when your thread is going from running state to a waiting state, then your program is moving from the user mode state to the kernel mode, right? Because thread is a kernel object. There is a associated kernel object with the thread. So thread is a kernel object. If your operating system is going to put your thread on hold, on waiting state, then in that case it's moving into the kernel mode, and which means that at least 1000 CPU cycles extra needed to move into the kernel state from the user state. And that is why this function came, initialize critical section and spin count. Here you have provided the critical section object, and then you have provided the number of times your thread should poll before it goes to the waiting state. This is this number is the number of time your thread which is waiting on the critical section need to poll for the availability of the critical section object before it goes to the waiting state. right? It's very simple, right? This 100 gives you the number of times it should poll. So what it does basically, it makes the transition from user mode to the kernel mode less probable. It removes the it not removes it basically reduces the probability of moving into the user mode into the kernel mode when when your critical section object can be made available within some fractions of seconds, right? In fractions of milliseconds. It may be that as soon as you moved into the kernel mode, your critical section object became available, right? And then all of a sudden you have to wake up that thread, right? So in a slice critical section, an spin count is useful for those moments so that it will reduce the chances of moving into the uh, kernel mode of a kernel mode for a thread always. It's every time you don't need to move into the kernel mode. It may be that you always get the critical section object as soon as you poll it for the 30 times or the 40 times, right? So so to avoid the scope of that transition from user mode to kernel mode, this is very much important and this is very much useful. Okay, so this was all about the critical section. I think I have covered almost everything, and you can try to run this program as well. Let's see what happens. The writer has got the time slice, so it's working fine. It will work fine because I have just called the initialize critical section and spin count. And always remember that if your system is single processor, then that spin count provided doesn't make any sense. That is not useful. But it's always good to use the initialize critical section and spin count, right? Because you never know that on which type of system is your program is going to run. So you can ask to the customer that what kind of processor they have, single processor or multiprocessor, then you can do this. Okay, so this was all about the critical sections, I think, and I hope you would have understood it. And if you have any doubts, queries, you can put in the link below and you can put the comments. And please subscribe. Okay, so I'm closing it.